so you said an example of, I might ask about independent variable being x. Can you just say that?
No. In the case of what I mentioned, that was for the brief calculations, where you've got the regression formula that will be in the output that I give you. I may ask what will be the value of the dependent variable when the independent variable has the value x. So, if you recall, the regression formula will be such that y equal to a plus b1 x1 plus b2 x2, for example, in a multiple regression. So if I give you the value for these and these, and I ask you what is the value for y, just plug into the formula. Or what will be the change in y if x changes from x to x x changes from 5 to 6, for example. What will be the change in y? Something basic like that. Any other questions? Regarding hypothesis testing, there is just one thing that we discussed at the weekend that we had. It's just a reminder that I don't mind how hypothesis testing is done. There's 3 different ways we can do hypothesis testing. Either do a confidence interval around the sample mean and check whether the hypothesized mean is within it or not. Either do a confidence interval around the hypothesized mean and check whether the sample mean is included or not. Or calculate the t-value for the sample data and then compare the t-value with the t-critical that we get from the table. So obviously, needless to say, if I ask you a question like these, I will put the table is looking in the exam. Okay. So if the t-critical, if the t-value is below the t-critical in absolute terms, then it is within. If you recall, when you do hypothesis testing, there will be a range. This is the acceptance area. That will be the t-critical. So if the t is somewhere around here, you accept. Otherwise, here or here, you reject. Yeah. Any questions?
Are there any particular examples you have that we can practice on? Because obviously the previous exams are regression and we can practice that.
I mean the one we're going to do.
The book is massive.
Yeah, the one we're going to do today is one example.
Are there any more?
Yeah, all the questions around that area. If you look at the book is massive, but the one that I choose, they come in a group of exercises on a particular area. So all that group of exercises. If you look, they got exercise throughout the chapter. So that section will be the main one.
Are you going to put the answers on?
They're there already. Yeah. All the answers are already on the sort of chapters we covered. Any more questions? So let's go and have a look at these exercises then. 956 was the first one that I mentioned, so let's just have a quick discussion about it and the other two. Hey! 956, page 379 of the book. Question A asks, is the significance level of a test is the probability that the null hypothesis is false? Is that a true or false statement? It's a false statement? Yes. What is the significance level? Remember here, the significance level gives us effectively these areas. And what are these areas? Are we accepting or rejecting the null hypothesis?
Rejecting.
Should we be rejecting or accepting them?
Rejecting.
We should be accepting them, and yet we are rejecting them. We should be, because they are underneath our distribution, but we accept that we will make an error around this area and this area where we will reject the null hypothesis, but we should accept. So, as it says in there, the significance level is not the probability that the null hypothesis is false, it's the probability that the null hypothesis is correct, but we are rejecting it. Yeah? Everywhere underneath these, the null hypothesis is true. But these, we reject the null hypothesis, but it is true. So the statement is false. The significance level is the probability that we will reject the null hypothesis, even though it is true. Okay? Second. Any questions before I move on? Second. So, when we put a probability distribution in a shape like this, everything underneath the distribution is true. So, whatever the variable is, it can take any value from anywhere in here to anywhere in there. The significance level cuts off this area and this area. And the significance level, say if it is 5%, it means that 5% of distribution will be here, and we will reject the null hypothesis if our value that we find falls anywhere in here. But in here it's still true, the null hypothesis. So we are rejecting the null hypothesis even though it is true, not because it is false. Okay. Second one says a type 1 error occurs when a true null hypothesis is rejected. That is true. Again, that's these areas, that's exactly what an error type 1 is. C, a null hypothesis is rejected at the 0.025 level, but is not rejected at the 0.01 level. This means that the p-value of the test is between 0.01 and 0.025. That's also true. Why? So if it is rejected here in this area, but not in this area, not rejected, that means that the p-value is somewhere in between the two. The p-value is the power of the test, or the level of significance you can have on the test. So it's going to be more than that because you're rejecting, but it's going to be less than that because you're accepting. So it's always going to be between the two. Okay. D says that the power of a test is the probability of accepting a null hypothesis that is true. Is that the case? It's false. P is the probability, the power of the test is the probability of rejecting H0 when we should reject it. Not accept one that is true, but reject one that is not true. That's the power of the test.
Sorry, can you just say that again?
Yes. So, statement says the power of a test is the probability of accepting a null hypothesis that is true. The statement is false. The power of the test is the probability of rejecting a null hypothesis that is not true. So, the probability of correctly rejecting a null hypothesis. That's the power of the test.
Like a probably very obvious question, what test?
The
Part of
test,
the test.
the test that we're doing on the value of the variable. So test, for example, that the average grade is 55% or 85%. So we are testing the hypothesis that the average grade is 85%. Yeah. So hypothesis testing is about looking at a variable that we are studying and make a hypothesis. So
Yes. It's just an question said the part of a test, so I wanted to know what test.
that's a hypothesis
Okay.
test. Okay. E. If a null hypothesis is rejected against an alternative at the 5% level, then using the same data, it must be rejected against the alternative at the 1% level. It's false. And that's a similar case. You can reject at 5%. So if this was 5%, you can reject because the value is here, but you don't necessarily reject at the 1%. Second one says, F says, if a null hypothesis is rejected against an alternative at the 1% level, then using the same data, it must be rejected against the alternative at the 5%. That is true. If you reject, that means you're here at 1%, at 5% is also rejected. And finally, G, the p-value of a test is the probability that the null hypothesis is true. It's false. The p-value is, it's actually the strength of evidence against accepting the null hypothesis. Okay? So these sorts of questions. Any questions? So let's have a look at 1029 in page 409.
Sorry, Carlos, I don't know if you'll cover this, but I must admit I get confused between which tables you're talking about. So the T and the P and the Z.